Hello everyone, welcome to EDUSYL. The previous videos we focused on uh, the wireless communications where we just run the basic UDP packet or UDP application that we run inside the host we kept already, host 1 to host 6. Now the same application, the same program we kept, but certain changes that we want to add, like where VoIP communication, like VoIP packet will be transferred from one end to another. And here I just changed all the devices which we have added, like you can say H1 to S2, which we have already designed in the previous video. There I just kept only host 1 will be the sender and host 2 will be the receiver. But in this video we are just changing those. We have already changed the code where both the end they will be sending and receiving. So in upcoming videos we are going to start from the scratch, but though we just started it, now our focus is we have to check. You can say it's a voice over Wi-Fi, so that's why it is named as View Wi-Fi. You can check here host 1, host 2, host 3, host 4 and host 5, host 6 are being attached. Now you can check the sources also, where the network name I have changed as View Wi-Fi and it is showing here as View Wi-Fi. Now you can check the INI file of it. In INI file you have to check the set time limit, that we have set this time limit as 10 seconds. Now the application which we have just run before that video, there we have set only one, where one application remain like the both the end, like host 1 and host 2. We just simply kept these things are one is sender, another is receiver. Now you can check the number of applications we have added is 2. Like host 1 number of application will be 2, like here application 0 we started, and application 1, the for the same host we are running 2 simultaneously. You can run 3, 4, 5. Next upcoming videos we will run like this. So number of applications we want to add, the number of applications will run simultaneously. So it's a mixed condition we are going to generate in upcoming videos. Now you please concentrate where exactly the voice over Wi-Fi will run inside without using an internet. Basically, VoIP we have seen generally there is an internet which through which the packet will getting transferred. Now without any Wi-Fi, without any internet, through an access point, we are going to transfer the VoIP packet. Now the same thing I have already discussed. Again, the thing I am going to tell you, the network you have to write the same network name. The View Wi-Fi is the network that we have created, and here the limit, the time limit we have set is 10 millisecond. 10 seconds. Now number of applications that we kept as 2. Here the app 0 for this application, host 1 will be the sender, that's why it is written as type name simple VoIP sender. This is due to the inet package, that's why we can write it better. Next you can say the destination address we have fixed is host 2, and destination port we have that discussed, though it's a peer-to-peer communication, so for both the host through which you are going to communicate should be same destination port address will be similar, local port address must be similar. Okay, because port address without the same port address we cannot exchange the data, that's why. Next talk time we have to add, because we have already discussed whenever we are just running a voice communication we should keep some certain delay through which it should create a real-time environment. Next host for application 1 we kept this as receiver. Why? Because host 2 we make this as sender for this application 1, so that's why it is receiver for us. Now for a 0 application, 0 means for the first application which we have named as 0, so host 2 is acting as receiver here. So in this way MOS also be kept as which is MOS spare time, like mean opinion score. Basically we kept certain time which to focus on the QoS. So now quality of service, which is QoS. Here the application 1 we have kept certain delay, play out delay, within that the packet will be generated and it will be transferred successfully. Here the same H3 H4 I have kept the similar codes for it. You can start with the first two also, not an issue, but these are certain codes. We started with the basic one, so six connections or six hosts we have kept. Yeah, the same thing. You can change the mode as AC or AX also. Here the antennas you have to keep and the bit rate you have to keep. So though we started with a G, that's why we kept here a Z. Here the QoS will not be compromised, so that's why we have just taken the WLAN, which is the wireless local area network. We kept this as QoS qualifier classifier. Next, we have said that the QoS should be properly maintained, so that's why we have written true there. And ARP we kept it as global ARP, which is address resolution protocol. We have to maintain it globally, no need to write it differently. We have just kept these things are globally. And here these codes we have already discussed in the previous videos, where the fragmentations, whenever you are sending the data, there should be a threshold where we kept the fragmented data. Now configure no aggregation, and aggregation and priority aggregation, three different things we have already kept. Where no aggregations means whenever you are sending the data, there should not be any aggregated packet you are going to send. That's why it is blanked. Type name we kept as blanked. Next, for configure aggregation, if you want to do aggregation, aggregation is of two types, either AMPDU or AMSDU. MSDU, or through MSDU you can segregate the data, and for MPDU also you can go for the aggregation of the data. So that's why we started from the AMSDU. So it is written this MSDU size we fixed as 1500. So based on this we kept the millisecond, the interval basically text will be this much. Now you can focus here also. First, priority aggregation, we kept the port address as 5000. Now we run to check whether it is running fine or not. So these are just the intervals we focus, and the main aim, you should have to set the time and you have to focus on the network, then only it will be created well. And now we focus on the no aggregation. In no aggregation we have to first start writing the things, like you can say for host 1 we have destination address as host 1 to host 2, so it is written here host 1 host 2. Okay, so these things we have to keep in mind. And the address, it also asks us for application host 2 it is host 1, because host 2 the destination address will be host 1. Okay, for host 3 the destination address we have already said for host 3 it should be host 4. Here you can check. Okay, host 3 to host 4. Here I have written the traffic host 3 has host 4. So here the application 0 for host 3, the application 0 we are sending to host 4. Here the same thing it is asking. Application 0 is it's host 4 now. Okay, now for the same question it is asking for host 4 for application 1. The destination address we have to write it properly, where what exactly we have written the code. If you're just changing it, it will not run. Okay, the host 5 application 0, the destination address is host 6, that we have already written host 6 as the destination address, that it is written here as host 6. It is asking to verify our data basically. Okay, so host 6 now we are writing the for same host 6, it will ask you for the application 1 what exactly we have written as host 5. You can check that one. Once you have properly been sent the information, then only a pop-up will be shown to you in a better condition. Yeah, this is what we are expecting. Now you can start a run the button, or you can press F5 to check the simulation. Due to visualizer we can visualize it. Here VoIP communications, that though we have already discussed, it is the both way communication. So any of them you could start sending the information. The host 6 it started, so host 5 should send you the acknowledgement. Here host 1, then host 2 will send the acknowledgement. Any of this could start the information. Now host 4, the host 4 is started, now host 3 will send you the acknowledgement. Yes, now it is done. So it is being getting transferred like 20 millisecond you focus here, 20 millisecond the packetization period that which we have discussed. For each of them will transfer the data. Up to this it is taking 20 millisecond. Now once the acknowledgement is given to all of them, now the second data if it is getting transferred, then it goes to 20 millisecond. Now it is 21. Now it will increment one by one. Here 30 millisecond, now 40 millisecond. You can check like one packetization period. Once it is done well, so all will transfer to or like host one will transfer to all of them present there, because it's a basically communication between all the devices everywhere. Like host 3 host 4 both will communicate, and host 1 to host 2 both will communicate. So certain information you can check where packet draft condition could be established. So everything we can keep in mind. So in this way we have completed this simulation using a previous code, through which we understood like how it is working. If certain changes we are going to add, whether that will run fine or not, that we have seen. Here you can change, it will be become 60 once it is completed. Here you can check 41, because 20 20 20 like this it will be incrementing. Now once it is 40, now you can check the microsecond, also nanosecond, also petasecond. You can check here it's 60. Now all will transfer the data. You can check yes, means third opposed. You can say pulled 3 means 3 data, means 3 packets which we have already generated, they have sent it well. Now we just stop it, and we can focus on the data which has been generated. You can check the ANF file, no aggregation. We started the no aggregation. You can check the browse data. Suppose I kept this two to check, suppose here this 4 I kept to check any bar plot if I want to create. So this is the bar plot where you can check interface cassette or a reception cassette. Like this we have completed the VoIP packet transmission between the wireless devices in wireless medium, where we kept the wireless medium as IEEE 802.11g standard, where the maximum bitrate we kept as 54 Mbps. Based on this we are getting the data, and we can plot it as per our wish. So you can check the drop also. So in this way we have completed a certain this part 2 video focusing on the target is VoIP packet transmission using this wireless medium. So thank you all of you, and have a good day.